So with our billing account in place, I'm going to start by opening up the code lab link that was provided. And so this code lab explains the exact use case we're going to be using to explore having a database-backed ADK agent that would allow for long-term memory, schema awareness in reasoning, and a very explicit example of how database schema awareness can inform your LLM responses and enable new patterns, such as the allocator that I'm describing here. This is a new pattern that I'm describing for my use case. And so the premise here is that I have a wide array of resources with specific parameters that I need to reason on, and I want to be able to provide exactly my data and have it applied to any use case I may propose in a very structured format. So I'm making the database connection, I'm stipulating the behavior that I want, because ADK is very good at that, and then at the end, we will actually see live on the ADK web what a response will look like. So the benefits here are that it's grounded, it's dynamic, you can very quickly define new tools with MCP Toolbox. The MCP Toolbox is a tool that allows you to securely connect to a variety of databases. Some are first-party, like BigQuery. Some are third-party, like Couchbase. And it's very adaptable. You can just, with simple config, enable new capabilities for your agent. So specifically, all we're going to need to get this project done is a Google Cloud project with BigQuery enabled, Cloud Shell environment, Java 25, which we will configure during the steps, and to sign in with ADC. So if you use the Cloud Shell and follow the steps, all of this will be taken care of for you. So to begin with, we're going to activate Java 25 on our shell. So we'll go to, as the link shows here, shell.cloud.google.com. You can just click that link. And you'll have to authorize it at first. And so what we're using here to specify the Java version that we're using for this session is a tool called SDKman. It is already installed on the Cloud Shell. I'm seeing that somebody has no, SDKman appears to be missing from this. That is interesting. Well, hold on. That's interesting. But in any case, we can use the Java version that's installed by default. There may have been a change recently to the Cloud Shell, but SDKman is a utility that's very useful for defining Java versions and installing them for use in development. But it's not a mandatory step to get this done, so we're going to move on with the installed Java version. And we're going to check that the Google Cloud project version matches exactly what we want. If you're in the Cloud Shell, you should see a yellow prompt that says exactly what the version is that you're using, or the project ID that you're using, and that should match when you enter the command to get value project. Just to make sure that this is the exact same value that you expect. Sometimes when you change sessions, when you leave it for a few minutes, that will differ. If this is different from what you expect, then you'd want to both set your project ID and possibly log in and set your quota project. All of these can have different environment variables that may affect which project is used. And if you type env, you can see the quota project that would be active for your session. So as long as those environment variables are in place, we are ready to proceed. So we're going to enable the BigQuery API. So gcloud services enable BigQuery APIs and AI platform. So this will enable both the BigQuery API and the Google GenAI platform API to be able to make queries to the LLM. And then we're going to create the sample data for this, for example. So we're creating a list of materials. In this use case, we are running a material science lab or a warehouse that has a number of different materials we can manufacture in. And we're going to evaluate which one of them is best for our use cases. So we are listing our materials and their conductivity, just a conductivity score as a float. So the BigQuery CLI has tools to make this easy. So we're just going to copy this sample and run it in our shell. And this will kick off a long-running operation. They're always called long-running operations, even if it takes only a couple seconds. But that will create the code, create the data set, populate it, and give us the result. So it says we have 4 affected rows. Let's go and confirm that. And ideally, if we are on track here and we don't have many questions, we'll have plenty of time to have Q&A and explore further reading. So here we are, conductive materials created, and we can see that we have the material name, the conductivity, and we can run a select star on this data set and just see what we have. We have aluminum, copper, gold, silver, and we know the conductivity of each material. Fantastic. That is enough data, specific data, for our LLM to reason on. Now we need to make sure that we make an ADK agent and that it has access to this schema and this data to be able to help us with our specific use case. Ideally, what I'm thinking of is kind of brainstorming. So any use case where you may have a team of people sit down and think laterally about how they can apply a set of resources to a variety of problems, a pattern like the allocator here would be applicable. So let's make it happen. I'm going to install the MCP toolbox, which is what's going to allow our ADK agent to interact with BigQuery. So to avoid a dependency on Node, we're going to actually pull down the binary manually and make sure that it's accessible. So we are creating a directory for it. We're curling the GenAI toolbox for the right version for our purposes. And in just a moment, when that curl is complete, we'll have it done. And of course, after this session is complete, this code lab is still accessible. You can feel free to use it as a jumping off point for your own ADK resources. I'm seeing a question in the chat that, do we need to curl SDKman into the Cloud Shell? It should have already been installed. This morning it wasn't. These are the things that happen with live demos, but we don't actually need it to continue. We should be able to forge on without it. And now that we have our toolbox installed, we're going to configure it. So this is where we define the tools that our ADK agent will be using. In this file, this is a simple YAML format that allows you to stipulate exactly what your data source is, what the material or what the tool sets that you want to give it, and the description of how the tool should function should be. And so it's a very flat and accessible way to configure agentic behavior with backing stores. So we're going to create the tools.yaml file. And so Cloud Shell edit opens up the file, the path in the editor above. And then we're just going to paste in the exact code here and make a couple changes. So we have the basic tools file here. We're going to configure our project ID, and we're going to say our source is conductive materials. And that's it. Beyond that, this file is as needed. It's sufficient for what we need. And you can absolutely curl SDK man if you'd like. We can, maybe I should show that for the, we can pause. Are we stuck on a step? Maybe this is a good opportunity to show the curl command. You can curl sure, we can set up the MCP toolbox again. So if you did want to set up SDK man, you can curl it into the shell, run it with bash, and then we can run the steps from the beginning to use Java 25 Tamarin, which is our suggested SDK. You may have to source your shell profile again, but okay. So we want to set up the MCP toolbox again. Let's back up to there. So again, MCP toolbox is a open source tool that allows you to interact with databases. It could be first party database, BigQuery, Alloy, or it could be third party like Couchbase. And specifically, what we're doing is we're pulling down the binary for MCP toolbox directly. You could run it through npx if you wanted to have the node package manager pull down and manage that dependency for you. I wanted to keep this as simple as possible with no additional dependencies. So I just said, let's pull down the binary and just make it accessible. So we are in step 8. We're copying MCP toolbox to its own folder, making sure it's accessible, making sure it's executable. And then the rest of our service will depend on that. In terms of how we're actually going to tell our project to use the toolbox, we have created a tools.yaml file, which is where we define what our BigQuery source is. And actually, we should not rename the myBQ source. It should be consistent with the source used here. So we're saying this is the source we want to use, and this is the tool we want to give our agent. So this will be a BigQuery SQL tool. We've defined the select, and then we're giving a description of how the tool can be used. This is what the agent uses to reason on when it should use the tool. So if you are defining your own tools, you should feel free to be as verbose as possible, as descriptive as possible with how you're describing your tool. Because it is, as with all things with LLMs, a non-deterministic reasoning request for the LLM to decide when to use the tool. And the more detail you provide here will help. I think we're caught up, so we're going to continue. Now, in order to have the agent call out to the Gemini API, we'll need to define a free tier Gemini API key, which we can do by going to AI Studio and defining it in an env file. For the sake of operational security, I won't be showing this step, but we will need to make sure that it is configured and make sure that our agent has access to it. So you can click on the AI Studio link. There will be a new set of agreements, and then we will create API key. You'll have to import the project you're using. And once it's imported, then you can create the key. So I'm going to do that off screen and put it into my shell. You should not share any API keys. That would give the opportunity for abuse of your account. Even a free tier, even with credits available, it is still good practice to avoid sharing API keys. So we're going to run the same command here. with the environment variable populated. And rest assured that it is configured. I'm seeing some questions in the chat about the tools.yaml creating an empty file. That is correct. So we want, when we run tools.yaml, let me bring my window back. When we run this Cloud Shell edit, it will create an empty file because the file doesn't exist yet. And then we should populate it with this content. And then once the content is there, we define our project ID right here. I hope that helps, Robbie. Now, for the actual bulk of the agent, we are from scratch just creating the basic requirements for an ADK Java app. So step by step, we are creating the ADK folder. We are we are creating the ADK folder. We are creating our POM to manage our dependencies. We're creating the agent allocator app, which is going to have our root agent. It's going to have our LLM agents, all of the definitions of behavior. And then for those who are more traditionally Java-minded, we can define a test. This will be a JUnit Jupyter test. And that is one way to test it if you wanted to use like Maven Surefire. But we'll also be testing it manually with the ADK web. So these, after explaining what those lines do, we will be running these commands. So I see a question, do we need to CD into the MCP toolbox? No. The install MCP toolbox step 8, will make the directory, change to it, bring the binary in, and then move us back. So it'll do everything you need to. And then as far as the API key, this will be used later on when we actually run the agent. I also see a question about the Vertex API key. Do we need to? Can we use Vertex API AI true instead of the Gemini API key? Yes, you can use Vertex with ADC if you'd like. I do like to demonstrate the Gen AI key implementation because I find that it is a more concrete path to show exactly how it's connected to your consumption. But that is up to preference if you prefer to do it another way. Now, configuring our POM. So we're going to, with the new files we just created, we're going to set up the dependencies for our project. So we're going to open our POM in the same way with our Cloud Shell Editor command. And then we are going to copy the contents here. So we are, actually, I see a good question from Himanshu. Where you're getting an SDK error, it will be easier if we just use SDK man to configure Java 25 rather than changing our POM. So why don't we refer to the command to curl SDK man into our Cloud Shell session and make sure that it's installed, which will then allow us to use the SDK use command from earlier. SDK use Java 2510. So then once we have our JDK installed, we're going to, let's step through the POM and see what we're doing. We're defining our project, which is the ADK allocator agent. We're using Java 25. We're pulling in the 0.8.0 version of the ADK, which I believe only was released about 2 weeks ago. Yes, Totoro, you may have to source either your own bash profile or the SDK init sh. Either one will work because SDK installation does edit your profile. So we have the ADK dependency, we have the dev dependency, we're bringing in MCP toolbox and enabling that to help us connect to our backing store of BigQuery. And then we have Jackson for annotations and JUnit for testing and assert for testing statements as well. And that's it. We have Surefire, we have compiler plugins, and we have exec maven to run a couple commands, but it's a very bare bones Java project. So we can take this after running Cloud Shell edit, it will open up our POM. We can take this code sample and paste it right into our pom.xml. And so now we have a folder with, let me actually open up we have, in our home directory now, we have the my allocator folder. This may make it clearer rather than editing each file one at a time. We have our MCP toolbox, which we'll be using to connect to our backing store. And then we have our allocator agent project, where we only have so far a main file and a POM file. So we have our dependency set up. Now we can move on to implementing the actual main file, the agent. So we're again copying the Cloud Shell edit command to open up the file we're trying to create, the allocator agent app. And top to bottom, we are pulling in a few agent classes from the ADK, from our ADK dependency. And we are using those as primitives to build our specific behavior that we want to work with. So we're defining our root agent, and this enables ADK to pick up which agent we're talking about. When we use ADK run or ADK web, it lets it know which class, which like set of behaviors to talk about. And then we're defining how we're going to connect to our MCP toolbox. As simple as possible, we're using stdio, and we are defining the tools file where we set it before. And then we are defining our tool set for our agent, which is the list of conductive materials. And here we're defining how we want the agent to act. We're saying you are an allocator. We want you to act solely based on your database. We want you to check what you have in supply, check what the demand is, verify that they make sense, and don't deviate from that data set. And so we are defining the behavior of our agent step by step, including phases of behavior. And this is an effective way to kind of corral LLM responses. And then we are defining the model we want to use. We're just using 2.5 Flash, and the tools. We use our toolbox. So this is how you would configure MCP toolbox to be used by an agent. You would just define it with .tools, and this is the benefit of using ADK versus just writing your own. You could do this with just the GenAI SDKs, but you would be writing much more code to have your Java class create an LLM agent, like reach out to AI Studio, have the model respond, pass your parts for text, and have the description and select your model. It would just be a lot more boilerplate. And so this saves you a lot of time re-implementing the same behaviors. And then for our actual main, we are just running in memory. We're starting the session, and then we're passing in the prompt that we actually send in. And so we can copy the sample code, and we can add it to our file here. And we can see that the change is reflected. And And that is the bulk of our editing here. And now, how are we following along? I see somebody asking about the declared package does not exist. Was that part of a stack trace when you ran it? Or is that perhaps an IntelliSense error when you count Kong example? It's probably an IntelliSense error. When you hover over here, it was probably saying this package doesn't exist yet. But it should exist if we did the create. The Cloud Shell edit should create the package that's describing com example 80K. So this is likely just IntelliSense lagging behind the actual file system state. And once you either give it some time or compile and run, that should clear. It should not stop you from actually executing the agent. Good question, though. So for the sake of completeness, I feel like it's just good practice to create a JUnit compatible test that you could run with Surefire. So we're going to do that, even though we're also going to be showing the actual agent running in 80K. So we're going to create our allocator agent test. And we are essentially just running an in-memory runner that provides a prompt in the expected format to test the agent and show that it invokes the tool, and that this is the kind of like parameterized testing you would use for agents. Typically, you'd say it needs to contain one of these things. You'd want to define a range of behaviors, a range of possible correct outcomes, which may be useful for your own testing later on. And so we've defined our agent test. There we are. And now we can run it here, but I think it's more interesting to run on the web. So we're gonna do that. We're going to, so Maven compile exec, what this does is the Maven exec plugin is it's a plugin that allows you to execute with given parameters, and like it allows you to pass for specific parameters to the JVM when you at build time or just after build time. So this is how we're going to be launching our 80K web server. This is the documented way to launch an 80K Java app. And so we're going to be going through with that. Again, you may have issues where your environment may not have been configured. If you do, let us know in the chat, and we will help you to resolve that. But in general, this should be exactly what we need. So let me just make sure that my key is set. And here we are. So we now run Maven compile exec Java with the port configured. Oh, it was in the wrong folder. So we'll need to CD to the my allocator folder. We'll need to be in the correct, we'll need to be adjacent to the POM when we run it. I should have included that in the steps. But once we have that, once we're in the right folder to execute this, Maven will pull down the dependencies, pull down a DK, and run the project for us. What was our error here? We must have misconfigured something. Let's see, let's run a Maven clean build. We have our correct Java version. Java. Oh, it isn't Java 25. Okay. Oh, I restarted the Cloud Shell session. That's why. SDK use Java 25 tem. That would do it. SDK install Java 25 tem and SDK use Java 25 tem. There we go. So that we'll need to install Java 25 tem and then use it in this session. That will resolve our build issues. And again, if you don't have the SDK command, I will type that in the chat here. You can curl it to your shell, and that will install it. And then you will need to source your profile, your bash profile, your ZSH profile, to reload SDK and put it into the path, and then you'll be able to use it. So we're using Java 25 in the shell, and now we want to maven exec and compile exec. We're running our main file. There we are. So we're using a Spring Boot web server under the hood. And so this runs on port 8080. The Cloud Shell has a web preview feature that we'll be able to use to preview it. And this will open up the 80K web interface. And I specifically wanted to use this to show, I enjoy the 80K interface to show exactly how I want my app to work. I like to use it at the kind of idea stage of the project to verify that the logic I'm using is sound and do a trace and show that the tools are being invoked, they're returning what I expect before I end up deploying and needing to undo infrastructure pieces. So we are, for this allocator, we're trying to see which conductive materials do we have and how can we use them. So rather than saying high frequency satellite wiring, let's say I want to build a thermometer probe. And I need to know which materials are, it could be thermally conductive, it could be electronically inductive. And so it is describing what it's doing. It's saying, I've configured it to explain exactly what it's trying to do. And so we can see that the agent is aware of our materials database. And there should be a little bit more detail here as well. Let me try a new session. And well, I can also pull up a session that I've run a little earlier, which shows in a little bit more detail the way these tools are also inherently slightly non-deterministic. But let me confirm that what I'm expecting here is showing up, so I can give you a richer example to work from. And I'm seeing some questions in the chat. It seems that yeah, SDK man was a bit of a stumbling block. But once we have the Java 25 Temarin running, we should be able to run the agent and have it again from the code lab here. We're able to see the tool. We should be able to see the tool usage. It may take a couple attempts. And now that is not actually what I expected. Let me pull up another example here. we getting any errors? No, we're not getting any errors. I'm seeing that. Let me see. Let me see some of these questions in the chat. I'm seeing that we're having trouble opening the web preview. In the top right, we should be able to click web preview, and that will open up a new session on port 8080. And that will bring us to our 80K UI as long as we're running the 80K web agent. As long as we're running the 80K web project. And here I have an example here. You don't see the Maven preview button. So it may be in the top right here, in the top right of the window. If you're in the shell.cloud.google.com, it'll be in the top right. It looks like a window with an eye inside of a diamond. And that will allow you to open up the 80K web. And I'll show one more time. I'll attempt one more time to show the more explicit tool usage. If it doesn't work, then I'll just move on to getting everybody running and explaining the logic in more detail here, and we'll open it up for questions. Here we are. So we have our first phase, which is resource verification. And so we're having it print. This is a mix of pulled data for the silver, copper, gold, and then we're also having it reason beyond there and see what else could be a reasonable response. And so this shows an example of working from the backend data that we provided and allowing us to start from the same ground truth and reason forward. So at this point, I can say, yes, these are reasonable considerations: corrosion resistance, wide temperature range, continue refining. And so there we have it. We have a schema-aware, database-backed implementation of taking a specific agent, giving it data, connecting with MCP Toolbox, and allowing you to interoperate with your data. Now, let's take a moment to make sure that everybody's at the same steps. I'm seeing some questions to explain the install and use SDK Java 10. Absolutely. So yes, it seems like a lot of people are having either Java version errors or API key errors. So let's address both of those. So to make sure that we have SDK man installed and the correct Java version in use, we can run the commands. We can run our curl. Actually, we can run our curl, which is curl SDK man, curl -s SDK man bash. That's the first command. And then we want to SDK use install Java 2510 and SDK use Java 25. So that is all three commands you'll need to resolve all the Java versions. For curling SDK man, we'll actually need to source ZSHRC and run all of the commands to install and use. So there's our troubleshooting fix for Java versions, running that series of commands to install SDKman, reinitialize from your bash profile, use install and use Java 25 will get you working on that front. If you're having issues with the environment key, the environment variable not working, I would set the Google API key. You would have to either export Google API key to equal your API key, or you can add that to the start of the command. And again, to generate a API key, you'll be able to do so through AI Studio. And then you can create API key and have it, and it'll show you the API key after you click create key. Again, these are secrets. You don't want to paste it in the chat or anywhere else. I'm seeing so it seems, Bill, you have the same Java version issue. So you'll need to run the set of commands that I've just pinned in the chat. Beyond that, if you have trouble running the sample, you are likely in the wrong folder. So you need to make sure that you are in the My Allocator folder, and then that will run our simple, our minimally viable allocator agent. Do we have any other questions? Is anybody stuck at a point? Yeah, Thomas, if you have ADK up and running, but nothing happens when you send a prompt, it is likely that you have an error in the console. So if you switch back to the Cloud Shell editor, you may see a stack trace. And if it shows at the top that you need to set the Google API key, then refer to the solution we put above. And it does make sense that you receive different outputs. This is inherently a little bit non-deterministic. Toolbox failed to initialize. Okay. Toolbox failed to initialize. That's a good question. So if we go to our MCP toolbox folder and the tools.yaml, we'll need to make sure that we have the correct project ID configured here, and that our source matches between the sources and the tools. Beyond that, the file should be correct as written. Yeah. I think I want to open the floor for any questions. We have a fair amount of time left. Yeah. Make sure you run it in a separate terminal, yes.
Any questions, folks? If you want to, I know you are unable to unmute right now, but please feel free to raise your hand. I'll mute conditionally. Like if there are specific questions that you're not able to ask in the chat, feel free to raise your hand. We see one question right now. What is the expected output for the sample prompt?
Let me try to show you here. So we'll grab our expected out here. And again, our tool calls will be a little bit different each time, but as long as we have the actual agent running, we should be able to see that we have our we have our toolbox running from the toolbox folder, and we'll be able to see in the chat as well in the side that it is initialized and ready to serve. Yeah, Sachin.
Hey, hi, Aaron. So
Yes.
when I try to open that, Cloud Shell edit my locator src main Java come example ADK, it is not opening actually. It is getting me error.
S- when you try to open the Cloud Shell editor for, sorry, could you repeat that?
This is step number 13.
13. Let's see.
Implement. Yeah, this one. Top one. Yeah,
Okay. So when you type Cloud Shell edit, um,
I'm not
you,
finding this path actually.
so the path, that makes sense. So if the file does not exist yet, it'll be created by Cloud Shell edit. Yeah. And let me go back to the, and so when you run Cloud Shell edit, it will either create the file if it's not present or open it if it is. I hope that helps. Yeah,
Yeah,
July,
it's getting me error actually.
it's showing you an error. Could you paste the error in the chat?
Yeah, sure. I already pasted basically. Let me paste again. Yeah, here you go.
Are you in the right directory when you're running this? Because it looks like you're
I'm under my location, my locator.
No such file or directory. Well, I would actually run that at root. So I would just type cd or at your home directory. So I'd type cd and then rerun that command.
Okay, let me try on the root also. After running cd. Yeah, now it is opening. Yeah.
Okay.
Thank you.
Yeah. Okay. July, any questions?
Hello, Aaron. Can you hear
Yes.
me?
Yes, I can.
So my question to you is, in real deployment situation, do you prefer API keys or service accounts for tools like this?
I do prefer service accounts because it allows for more granular control of IAM. As far as security, as far as metering usage, especially for short-term projects, I find that API keys are handy. You can check on the AI Studio dashboard exactly how much you're using. You can set budget limits. And so generally for code lab environments, I prefer API keys. In production, I would probably lean towards a service account.
Okay. That was my question I wanted to ask. Thank you, Aaron.
No worries.
Let me turn off recording and
Sounds
we'll
good.
take maybe a couple of questions more because we have 20 more minutes, but we can take a couple of questions. And if there are not many, we can wind up the session. So you have at least 15 minutes back.